Hey everyone, and welcome to Chef AJ Live. I'm your host, Chef AJ, and this is where I introduce you to amazing people like you who are doing great things in the world that I think you should know about. Well, back by popular demand is my guest, Dr. Peter Rogers. He's been on the show before, and you guys have said it's like attending a medical school lecture. This guy is so knowledgeable. He's done talks on this channel about dementia, disease prevention, atherosclerosis, diabetes. And today we have a very important topic. It's about what you maybe would consider doing if you had cancer. It's called What I Would Do If I Had Cancer with Peter Rogers, MD. And cancer has touched my life very profoundly. I was diagnosed with precancerous polyps in my 40s, which was what caused me to change my diet in a positive direction. I've had over 10 family members die from cancer, such as pancreatic cancer, bone cancer, bladder cancer, breast cancer, colon cancer, and many of these were first-degree relatives. So I have a very strong history of family cancer, as I'm sure many of you do. So please welcome Dr. Peter Rogers. It's great to see you again.
Yeah, thank you.
Well, I know you prepared a fabulous presentation for us, so if you'd like to get started, I am all ears.
Okay. Well, the vegan movement needs some art. So here's our first painting. We've got Big Meat in the ring against Dr. McDougall right here. Dr. McDougall lands one. We got Chef AJ with the round cards. We got some of the coaches over here. I wanted my kid to add more people into it, but, you know, he ran out of time. I didn't want to push my luck with him. So anyways, that's our first artwork for today's show. Okay, now here's the diet nirvana pyramid. And, you know, we start out at the bottom with paleo, keto, low carb hell for morons. All right. Then the next step up is the sad diet, fat, sick, stupid, unattractive, untouchables, minimum wage, proles, dead at 50 to 65, drinking tap water. The next level up in the diet nirvana pyramid is Mediterranean diet. And this is sort of for pseudo intellectual ignoramuses like Ivy League faculty, bottled water. They eat cheese and wine, dead at 55 to 75. Next level up is the lacto ovo pesco vegetarians, the middle caste, the bourgeoisie of nutrition world. Carbon water filtered only, half screwed, dead a little bit later, 60 to 80. Next step up is the philosophic vegans. No animal food, that's progress, but tons and tons of fat stuff, including oils and whatnots and sweets. So they make it a little farther, a little less cancer, but they're still not that healthy. No processed food, another jump up. No sweets. Whole house carbon water filter. Kitchen reverse osmosis filter. Good progress. Get an extra 5-10 years. The next big step up is no oils. That's real progress. Junior nirvana level. No sodium added. Assistant nirvana level. No nuts, seeds, soy, or avocado. Associate nirvana level. And then the apex. Organic only, fruits and veggies and starches, full nirvana, expected lifespan, 80 to 110 years, towards the far side. Okay, the next thing is, I'm going to be talking about cancer today. And so the real question is, how in a million years could I say unconventional things about cancer? And here's some of the rationale on two sides of the coin. You know, it's been shown a lot of conventional medicine is really not the first choice for a motivated person. I'm going to go into standard of care in a moment, but a lot of people automatically assume standard of care means optimal care. And actually, it doesn't quite often. Sometimes it does. Quite often, it means lowest common denominator for unconscious patients, intoxicated patients, cognitively impaired patients. There's often an optimal level of care that can be obtained, but it requires the individual to do a lot more. For example, you can't cure coronary artery disease with stents or surgery, but Esselstyn's shown you can cure it completely with a low-fat vegan diet. You can't cure hypertension with a pill, never, zero. But it's routinely cured if it's caught early enough with diet, low-fat vegan diet. Pills don't work so well for type 2 diabetes. You can never cure it, okay? Low-fat vegan diet routinely cures type 2 diabetes if caught early enough. And what I'm trying to say is people say, well, so what? You cure diabetes, big deal. Well, actually, it is a big deal. Diabetes is associated with obesity. Obesity is associated with increased estrogen production and a whole bunch of other complications. Hyperglycemia, increased epithelial mesenchymal transition in cancer. Immune suppression associated with increased cancer. High insulin causes a drop in the production of insulin-like growth factor binding proteins. So what that means is there's more available insulin-like growth factor inside the blood going to the cells. Well, what does that mean? It means increased activation of mTOR. That's a nutrient sensing pathway that tells the cell to replicate. So what I'm saying is once you have diabetes, you've initiated a whole bunch of processes that increase cancer risk. And thus, if you can stop diabetes, you've stopped a whole bunch of things that increase cancer risk. Okay, it also causes endothelial dysfunction. That causes tissue hypoxia, increased cancer risk. Also, diabetes associated with increased advanced glycation end products, and then also thickened capillary basement rendering, more hypoxia, more cancer. Okay, and it just keeps going on. Diabetes, oxidative stress, inflammation, advanced glycation end products. And there's more stuff here. I got whole articles about that. I can give whole lectures on that. So what I'm saying is you're actually solving a lot of the problems, the risk factors for cancer. And the pills don't work so well for obesity. You can cure obesity pretty easily if you go low-fat vegan, okay? Let's see, pills don't work so well for attention deficit, anxiety. Well, I'm kind of getting another ballpark there, but low-fat vegan often significantly improves mood, and in the long run, it does relatively well. The doctors who figured out most of the most common diseases, they're not even in the textbook. Believe me, I've gone through all the textbooks. Hypertension, Kepner and Moore, they're not in. Coronary artery disease, Ornish and Esselstyn, they're not in the books. Abdomen diseases, Burkitt, he's not in the books. Autoimmune disease, Swank and McDougall, he's not in the books. Diabetes, Brownlee and Shulman, they're not in the books. Cancer, Farberg, he's not in the book. So what I'm trying to say is lots of the best information, it's not in what one would call the standard textbooks. And I would even go farther. I would say if you really want to understand a lot of diseases, you have to read outside the conventional textbooks. Conventional textbooks have useful information as far as they go, but there's a ton of stuff that is outside of them. It is beyond them, okay? I wish I learned all this stuff when I was young. That's partly why I'm giving this talk. I was pissed off. I graduated first in my class, 99 boards in med school and residency, and I couldn't save my mother from cancer. And there were other things in my life that I wasn't able to handle. You know, my girlfriend, her mother died from lupus because I didn't know. I just figured at that time when I was young, you know, medical student, well, you just send them to the specialist and hope for the best. It never occurred to me when I was young that I could read and learn all these things myself. And now I've learned that one can do a tremendous amount of learning about these diseases that's very beneficial to help their patients, their family, themselves. Okay, so, you know, conventional is always going to be obligated to go by that standard of care, which again is good in some ways, but it's not so good in other ways. Okay, what else? You know, the other question is, are we living in the golden age of high-tech medicine, or are we in the dark ages giving people, you know, too many drugs that don't work when there's other options? And cancer is largely a diet-related disease, so maybe fixing diet and lifestyle in the ways I'm going to talk about might be helpful. Okay, standard of care, like I said, it's a lowest common denominator. You know, you have to have a standard of care to make sure intoxicated, unconscious, demented people all get reasonably good care and that everybody knows what's the minimal required standard. But if you want optimal care, you have to be involved and educate yourself and train your behavior. And you can't judge doctors only by outcomes, because if you did, nobody would want the really sick patients. They would be shunned like leprosy. So there's a reason for the standard of care and a good reason for it. But outcomes-based medicine, which is a great thing, is never going to happen because it would give too much prominence to the vegan diet that wouldn't be profitable. So it's always going to be EBM, evidence-based medicine, and evidence-based medicine sounds good, but it's really not as good as one would think. Okay, so here, this is a disclaimer. Why should you not take me seriously? First of all, I am not a cancer doctor. I do not take care of cancer patients. I am not a cancer researcher. I am never in charge of any cancer patient other than like a family member who I'm helping out. I am not well informed on all the different types of chemo. I am not well informed on all the types of repurposed drugs. I am not well informed on the nuance of radiation therapy or the nuances of surgical therapy. I was an interventional radiologist, imaging guided surgeon in the past, so I did a lot of procedures, but certainly not the big open surgical procedures. All the ideas that I'm talking about here are theoretical, based on my study of the subject. And I'm also going to talk a little bit about anecdotal survivors, which I realize they might have eaten a vegan diet, but that doesn't mean the vegan diet is what cured them, because theoretically, there are lots of patients that have spontaneous remissions. Is it because of the vegan diet or not? Now, that's an interesting subject. We'll come to that in a moment. Also, what I am saying, I am contradicting the somatic mutation theory. Make no doubt about it, because it is wrong. It's been refuted, and that's important to know. And that's one of the reasons why I think there's a problem with some current conventional cancer therapies, because they're holding on to the somatic mutation theory, like trying to say the earth is flat. And it's like Ptolemy in astrology, and they're adding on all these epicycles. Whereas when you move to the mutation theory, the metabolic theory of cancer, it's a big deal. Metabolic theory of cancer, tons of things will make sense. You'll be able to understand all kinds of things, and it'll be a guide to many of the things you can do. Okay, so now why maybe you should take me seriously? Well, you know, I was triple boarded. I had obtained board certifications, diagnostic, interventional, and neuro. I've done over 1,000 biopsies. I've been through all the emotional stuff when my mom went through cancer, plus, you know, my patient experience to some extent. I was first in my class in pathology, et cetera. So I've really studied this a lot. I wanted to understand cancer. I was very upset that my mother had died. And at the time, I didn't know how to do anything better. I wish I would have a chance to help her again and do it over. Okay, my theory about treatment, let's see. Well, basically, what is a disease? Think of disease not just some macroscopic thing, but at the cellular level. There's too many bad things happening to the cell. Try to avoid those. And if the cell's deficient in some good things, try to increase those. In that simplified way, you can think better about health and nutrition and preventing cancer. And again, I believe that humans have a species-specific diet. And when you optimize that, everything in their health tends to improve. And like I said, we know that low-fat vegan can often cure the common chronic diseases. Cancer seems to be highly related to that category. The risk factors all go together. Populations with these chronic diseases also get much more cancer. So maybe this whole lifestyle and cancer thing will help. Now, here's a quote from Chris Wark. He wrote a book called Chris Beats Cancer, and he's a long-term survivor, about 20 years from colon cancer that had spread. And here's what he said. He said, to just go for surgery and chemo is easy. You just sign a consent form, and that's passive. To study cancer, to completely change your diet, your exercise, your habits, your attitude towards life, that is difficult. That takes a lot of effort. That is active. And that's kind of, I exactly agree. And now there's a lady by the name of Kelly Turner. She wrote a book called Radical Remissions. It's a good book. She's real good on the psychology. She still hasn't fully got there in terms of nutrition, but she's great on the psychology. Dr. McDougall and others have collected papers, lots of spontaneous regressions. Dr. McDougall has collected a bunch of papers showing improvement with low-fat diets. I looked them up. There's a whole bunch of papers on low-fat diets leading to better outcomes for multiple different types of cancers. And here's what I'm trying to say. We already know you get better results significantly with low-fat diet, but I'm not going to stop there. I'm going to do everything possible if I had cancer to minimize the likelihood that it would progress. I wouldn't just eat less animal. I think it's stupid to say, oh, just, try to cut down a little bit on your meat. No, zero meat, nothing from an animal, no dairy, no fish, no chicken, none of it. Okay, all that animal protein is a tumor promoter. The next thing is low sodium, no added sodium for good reasons. I'll explain why coming up. Organic only. I think there's terrible herbicides in organic. Believe me, I read an entire book on the biochemistry of herbicides. You don't want them if you have a choice. If you're starving, you got to eat what you got. But if you're not starving and you have a choice, organic only is my opinion, especially if you got cancer. Water filter, you got to filter your water. We'll talk about why. Exercise is much more beneficial than you realize. Tons of these metastatic cancer survivors were all big into exercise. You got to get your sunshine. That's the best vitamin D. So you get that more active vitamin D3 form that helps prevent cancer. Iron, watch out for iron. We'll explain it. You can easily minimize that. No processed food at all. Like I said, you get rid of, there's all kinds of chemicals in processed food. We're not made to eat that stuff. The only exception I'd make would be one ingredient only in quinoa or oatmeal. That's it. Okay, salads. We'll talk about salads, greens, all these metastatic cancer survivors. I studied some of them. Man, they all eat tons of salads. Okay, no alcohol, no tobacco, no caffeine. Do something to help each other. You get these reward neurotransmitters released in your brain when you help each other people. So you not only help them, you help yourself. Maintain social support. Religion helps a lot of people. And, in modern society, everybody, sort of makes fun of religion. Let me tell you something. They're the longest lived people in the world. They have higher levels of performance from what I've seen in multiple areas of endeavor. So don't underestimate the benefits of religion. I'm going to show some examples of that too. And the music, pleasant music is very soothing. That lowers stress level. And that's a big thing. All of these cancer survivors, I read the whole book about them, a couple of things about them. They would figure out a way that they could get themselves into a positive state of mind, the attitude of gratitude and all that. Because when you're in a positive state of mind, you go into more parasympathetic autonomic nervous system, PANS, you lower your stress level. That means you lower your cortisol, you lower your catecholamines, and then you activate. So those are the emergency fight or flight hormones. You want to be more in a relaxed state whereby then your immune system kicks in and heals you better. Okay, having a purpose. So anyway, here's a couple papers. Effect of low-fat diet, big improvement in cancer survival. Here's another one. There's tons of papers like that. All right, here's another example. Let's look at lung cancer. The patients from United States had much more fatal lung cancer than those from Japan, even though the Japanese were smoking a lot more. So why is that? And it's the same thing with the Papua New Guinea, okay? They got much fewer. I'll show you the slide for that. So here's Papua New Guinea. We got 6 times. Here's their numbers. 1.1% dying from lung cancer in the United States, 6.2. 6 times as many people dying from lung cancer, even though they're smoking like chimneys over there. Same thing with Japan. Far more cancer deaths in the USA. Why? Because on top of the smoking, we're also eating the high fat diet. We're also eating the high iron diet. All that beef, for example, puts lots of iron in. Iron causes problems. It worsens cancer risk. That's not widely known, but it's true. You can minimize that. Okay, here's a format for my talk, just so you know. Some people, you realize I'm going to start out saying real basic stuff. We'll call this basic useful info. Anybody can understand that. Then I'm going to go up into a little bit more complicated stuff and connect some of the different fields. And then AO means academic orgasm, okay? But then I'll come back down. So what I'm trying to say here is, yes, I'm going to get a little complicated, talk a little bit of, medical jargon, biochemistry stuff, but I'll come right back down to common stuff. And I think you're going to enjoy it. And I'll try not to spend too much time on stuff that's too complicated, but I think it's always going to keep coming back to the main points. And I think it'll be pretty straightforward for you. Okay, here's the history of medicine. If you went back before 1900, therapeutic phlebotomy, drawn blood was sort of a mainstay. And it's good for a few things. It makes the blood thinner, it lowers blood viscosity. But, a lot of the medications in those days were worthless. In the 1900s, there was more pharmaceuticals, and the pharmaceuticals did improve, and the surgery certainly improved a lot. You got laparoscopic surgery, you got interventional radiology, imaging guided, CAT scan guided abscess drainage, etc. In the early 2000s, I saw a tremendous improvement in all these mechanically implanted devices, pacemakers, automatic defibrillators. So what I'm trying to say is medical progress is being made. It's most powerful conventional medicine in treating acute problems, fixing a fracture or a trauma and all this other stuff. It's also good in, end of life situations like kidney failure. Put the person on dialysis, they can live a long time on that. I've seen dialysis patients alive 10 years later. Okay, but they're still not that great at treating the chronic diseases. That's why they're called chronic, because they can't cure them. Okay, and these are some of the fancy things. We're not going to talk about that too much, but what I'm trying to say is these old-fashioned basic things, which, your grandmother could have told you about, they're really not well understood. Most people do not understand these things. Believe me, I spent years studying these things, and there's a lot to know about them, and they'll help you. And they're all free. That's another reason why they don't get taught or promoted, because they're free. But they're powerful to improve health. Okay, and here's what it basically kind of comes down to. You've seen this before. If you don't start getting your act together by 35 years old, the sooner the better. You go the low-fat vegan route, you got a good chance to keep the Johnson working up into old age, not take any pills. I'm 59. I don't take any pills. I'll be 59 very soon, 58 and much. Okay, no surgery. That's what you want. And then you die of old age, 90 or older. You go down the meat and processed food, man, you're headed for trouble. Drugs, you're going to get drug after drug after drug will get added to your list. Chop, chop, chop surgery, bye-bye money, dead, cognitively impaired at a relatively young age. You don't want that. Just letting you know. Here's a typical American. Coronary artery disease, time for a stent. Stent's not working anymore. Time for a cabbage, coronary artery bypass graft. There's a scar. Those gallstones are racking up. Scar here, appendicitis here. You don't want all that stuff. Taramata, eating a plant-based diet in northern Mexico. So this is a comparison here. You probably heard this, a lot of you before, the people who know me. The Tarahumara in northern Mexico, Copper Canyon, Sierra Madre Mountains. They're running around 100 miles in 2 days, every guy in town, not just a fast guy. Whereas the Pima, they were together joint populations before the Mexican-American War in 1848. The Pima, they've eaten the standard American diet. They got tons of health problems and obesity and everything that goes with that. Okay, so just to show you, here's a comparison of diets. Here's a standard American diet, high in saturated fat, moderate amount of oils, end up with a lot of health problems, especially coronary artery disease and a lot of cancer. You go to East Asians, that's like, Japanese, Chinese, Koreans. A lot of them eat tons of sodium, so a lot of gastric cancer related to that, a lot of hypertension from all that sodium. And then here's the population, people from India, South Asians, and they have surprisingly high diabetes. And I couldn't figure out why. I think it's because they have too much oil in their food. They eat a lot of fried food. And that's, the Yamashita theory of, injury to pancreatic beta cells. Okay, but what's the good news in all this? Low fat, low sodium vegan, they don't have any, very low in fat. Okay, they get hardly any diabetes, hardly any, next to none. Hypertension, myocardial infarction, stroke. It's a no-brainer. If you study this, there is no controversy. It's obvious. It's the best way to go. Okay, it's like going to Las Vegas and winning the slots. Everything lines up. Live longer, be thinner, prevent diabetes, prevent coronary artery. You keep looking good, being thinner longer, prevent impotence, prevent cancer. What more do you want? That's as good a deal as you'll get in anything in health. Believe me, I studied everything in health that could be studied that I'm aware of. And that's the deal. Okay, now I got to tell you a story. Before we get to the cancer stuff, this is one of the vegan stories that I like you to see what you think of it, and then I have a question for you at the end. This is the story of the zookeeper or the doctor. Who knows more? Once upon a time, the zookeeper for the herbivore monkeys went on vacation. A medical doctor locally agreed to moonlight at the zoo. He figured his experience with other talking primates would serve him well. Unbeknownst to the doctor, the new commissary intern had been feeding the monkeys the same diet as the jaguars. This is known as the Jagoff diet. The herbivore monkeys got sick and were too tired to climb the plastic trees in their cage. Paradoxically, the female monkeys seemed happier because the male monkeys are no longer trying to mount them. The MD gave them pill after pill, which slowed things down a bit, but the monkeys kept getting sicker. It took 2 pills to control the high cholesterol for the monkeys, 3 pills to control the hypertension. The MD also ordered an endocrine consult for the monkeys' worsening diabetes. Perhaps a continuous glucose monitor with an insulin pump and artificial intelligence auto-programmable insulin dosing might help. The MD also wisely consulted the cardiac surgeon to evaluate the monkeys for open heart surgery for coronary artery bypass grafts consideration. The surgeon went through the standard consent for coronary artery bypass graft with the monkeys: graft occlusion, myocardial infarction, heart attack, chronic arrhythmia, permanent pacemaker, kidney failure, cognitive impairment, stroke, death, painful death. The monkey was scheduled for the operating room the next day. Then that morning, the zookeeper returned from vacation. The operation was postponed. The zookeeper put all the monkeys on a low-fat, plant-based diet. The monkeys came off all their pills and made a full recovery. However, the male monkeys started again trying to mount the female monkeys. One of the female monkeys filed a complaint that the zookeeper was a misogynist, and the zookeeper got fired. Then all the monkeys died. And so here's the question. What was the zookeeper's name? William Kempner, perhaps the greatest doctor who ever lived, the rock star of the vegan community. Allegedly, lots of stories, but we'll talk about that some other time. He had the best results of any doctor ever in the history of the world. You should read about him and learn about him. Okay. All right. Now, what's this stuff about nutrition as an adjunct therapy for cancer? Dr. McDougall, wrote a paper about this around 1982. This information has been around a long time, but almost no one knows about it. Here's a paper, talking about cancer pathophysiology in a 1990s article, and it said they were able to show non-cancer cells turning into cancer cells turning back into almost normal cells. And this is very much like, I'm not saying that can definitely happen. I'm just saying that's what the article says. What I'm saying is this is very much, it echoes T. Colin Campbell's work in rodents, where by adjusting the amount of animal protein, he could make the tumors progress or not progress. Okay. Now, obviously, that's a simplified setup, and we're going to talk about that more in a little bit. But the point is, there's a plausible biological mechanism for some of this stuff that's worth knowing about. Okay, lowering the fat, we talked about that, low-fat diet, and then here, just to give you an example, there's lots of people who had spontaneous regressions of cancer, got totally better. So there's always hope. And not only is there always hope, but that Kelly Turner went and studied them, and some other people studied them too. This guy, Harold Foster, he studied all these patients, and what did they find? You're reading a medical journal and it just says spontaneous regression of cancer, as if it was just a miracle, okay? But the truth is, when you talk to these patients, Kelly Turner's got, went to a whole bunch of them, interviewed like 1,000 of them. Every single one of them said, no, I totally changed everything. I changed my diet. I changed my attitude. I changed everything. So that's what I'm kind of saying is the medical articles don't tend to talk to the person. That's a mistake. They always assume whatever they did medically is what did everything. They don't actually ask the person, how do you eat? How do you sleep? How do you exercise? All that. There's been other experiments showing that, changing to phytonutrients, plants, if you will, having increased ability in, laboratory settings to control cancer for what that's worth. Okay. This is another paper on spontaneous recurrences. Okay. Now here's a big paper. This is one of what I would consider most important things in this whole talk. Quantitative cell shedding in a mammary tumor. Okay. And what they showed, now these were in rats, but rats have very much overlap with humans in their physiology, pathophysiology. They showed that a 1 gram tumor, pretty small tumor, all right, it would shed over 3 million cancer cells per day. All right. What does that mean? What that means is there's going to be cancer cells in the blood. There's nothing you can do about it. I guarantee you there's cancer cells in the blood. So your immune system is great at taking care of it. Your immune system is what saves you. Remember that. That's an important point. It is your immune system which must remove the cancer cells from your body. So you want your immune system to work well. Trust me, that is as important a thing as you could ever know. The immune system is needed to remove cancer cells. Therefore, if you want to be healthy and not progressing cancer, you want to have an optimal function of your immune system. And once you take on that thought, a whole bunch of things tie into that. optimize immune function. Now, here's another thing. This came from a nice talk by Dr. McDougall about cancer, whereby, if you go through cancer, you can look at the doubling time, all right? Cell of origin doubles typically in a ballpark average of about 100 days. So 200 days, you got 2 cells, okay? And then, another 100 days and so on. So what's the point? Anything you could do to just slow down the growth of cancer. Let's say your cancer started and it was going to kill you in 25 years. Well, if you can drop the doubling time, make it twice as long, 200 days to double, you could die 50 years later from the origin of cancer instead of 25 years later. And by that time, you could die of something else. So that's kind of what I would do. And again, I'm just talking about what I would do. Most people, they're not that motivated or lazy. They're not curious. They don't want to read or learn. This is just what I would do. I'm not telling anybody what to do. I'm just telling you what I would do. Dr. McDougall says, basically, because the cancer tends to metastasize early before it's detectable on most imaging modalities, it's virtually almost always metastatic before you can see it. Now, on a CAT scan of the chest, you can see lung nodules when they're pretty small, but you don't know they're cancer initially. There's tons of times you see a 5-millimeter nodule. It's from when the kid had, something when he was a kid, okay? It don't mean it's cancer. You got to follow it up. You got to get a CAT scan 10 months later. A lot of times when it's still small, you can't really tell. When it gets up closer to around a centimeter, it might start becoming obvious. It's really cancer. But by that time, almost always, it's metastatic, all right? And now we're going to talk about, is that cancer a rabbit or a vulture? Those terms will make a lot of sense in a moment. Okay, and most of the time, the cancer doubling time for the metastases is about the same as for the primary tumor, where it begins. Okay, and so in general, that's a reasonable number. We're not sure it's cancer until it's at least a centimeter, and by that time, it's probably metastatic already. Okay, you got to know a little bit about cells. This is all pretty easy. It's mostly just like vocabulary. Prokaryote. Pro means pre, sort of in Greek. Karyote means nut, and that comes from the nucleus. So prokaryote means like a bacteria. It's a cell with no nucleus. So these are single cellular organisms, all right? And we need to know about bacteria because cancer is almost like a bacteria. Here is eukaryote. Eu in Greek means true, karyote, nut, true nut. So where that comes from, this is like human cells, is you have a true nucleus. But I'm also going to tell you, like so many things in the books, that's not the money. The money is eukaryotes got mitochondria. Mitochondria means tons of energy. In general, you can think of mitochondria mean 18 times as much energy. That's a lot of energy, all right? So you can't have a multicellular organism without having mitochondria. All right, here's a typical metabolism. Glucose comes into the cell, hexokinase is the enzyme, phosphorylates it, runs through glycolysis, then you have an end product, pyruvate, goes into the mitochondria. This is Krebs cycle, and then electron transport and all that for energy production. That's how things normally go in a regular person, a healthy person. Here's another thing now. In a cancer cell, now things are going to start going different. The glucose comes into the cell. There's increased amount of these things, glucose type 1 transporters that just want to, like a vacuum, trying to suck in the glucose. And after it goes to pyruvate, a lot of it gets pumped out of the cell as lactate. Simultaneously, you're going to pump out protons, acid. And now here's one of the big points. This is another AO moment. Glutamine, which is an amino acid, perhaps the most abundant amino acid, it comes in the back door through a glutamine transporter, and it goes right into Krebs cycle, and it can get converted to glutamate, then to alpha-ketoglutarate. So the point I'm trying to say is, cancer cells don't need your glucose. They could run on glutamine. That's why you can't win the game of cancer if all you think about is glucose. You can't forget glutamine. It's essential to be aware of that because it'll affect what a person does. So remember that. Glutamine coming up the back door, it can also feed cancer. Now, here's another important concept. Upregulation of insulin. IGF and ILGF are the same thing. Insulin growth factor or insulin-like growth factor. Okay, so the cancer cell makes more receptors for these things. So that's what makes the cancer cell more dangerous, is it is sort of hot to trot and ready to go. And I'll show you. So here's a bacteria. Glucose to pyruvate pumps out lactate. It's a simple anaerobic bacteria, meaning without oxygen. Now, here's a normal human cell. In the presence of oxygen, glucose goes to pyruvate, and the pyruvate primarily goes into Krebs cycle, gets converted to acetyl-CoA. You produce electron carriers, NADH, FADH2. They send their electrons over to electron transport. The protons are pumped into the space between the inner and the outer mitochondrial membrane. You make tons of ATP, and you blow off CO2. You want to blow off that CO2 as a waste product because that causes vasodilation, gets more blood flow to the tissue. So that's normal human cells. All right, now I'm going to show you cancer cell. This is also one of the most important parts of this talk if you want to understand cancer. The cancer cell, it is a cell that has been damaged. It's mitochondria, damaged usually by hypoxia. It could also be damaged by other things that cause mutations, mutagens, We'll talk about those, like a chemical insult. It could be a genetic problem in the enzymes of the mitochondria, but either way, So the normal human cell is a worker. It's got stuff to do. We'll talk about that more in a moment, but its job is to do its job as part of an organ. If you're a liver cell, you do what the liver does. If you're a kidney cell, you do what the kidney does. Cancer cell says, screw it, man. It's like Johnny Paycheck. Take this job and shove it. Okay, I'm not working. I don't have enough energy. I don't have oxygen. I can't be making all that ATP and working like a worker. I just want to survive. I'm going to replicate myself. I'm going to go find an apartment somewhere else. So the cancer cell does lots of strange things. It gets lots more of these glucose type 1 transporters to suck up glucose like a vacuum. It gets more CD36 membrane transporters to pull more fat into itself, more iron acceptors, transferrin receptors to get more iron into the cell. You need iron to replicate. Remember that. You need iron to replicate. That's a very much controllable variable. Okay. Glutamine coming in the back door, also feeding the cancer, and that could be sucking amino acids off the person's bodily protein, causing cachexia, making them kind of skinny, weight loss. Okay. You also get these MCT4s, monocarboxylate transporters, and that's what the pyruvate is then converted to lactate. That's pumped out of the cell along with protons. So it causes an acidotic effect in the tumor milieu, the tumor microenvironment around the tumor. Okay, that's called the Warburg effect, by the way. When a cancer metabolizes anaerobically, even if there's oxygen present, it sends its pyruvate to lactate. So you need to know Warburg effect. That's going to come up again a lot. Okay, Otto Warburg, the guy who figured it out, won a Nobel Prize for that in 1931. Okay, and then this conversion of pyruvate to lactate is called fermentation. The cancer cell also has upregulated, that means makes increased amounts of insulin-like growth factor receptors, okay? It wants to grow, and it's going to suck whatever it wants out of the blood. So it is primed to grow. It is hot to trot, all right? And in so doing, by stealing fat and iron and more of the insulin-like growth factor hormones, more glutamine, more glucose away from the other local cells, it outcompetes all the cells in its environment. It takes over. It's like a gang of bullies that takes over a neighborhood. That's what cancer is. And here's the most important thing almost all cancer cells share this change in common. HK2 means hexokinase 2. So that's, instead of having hexokinase 1, which I sort of showed a moment ago in my picture about metabolism, they upregulate, make increased amounts of hexokinase 2. Hexokinase 2 grabs onto the mitochondria. This is a mitochondria, and they attach to the outer mitochondrial membrane. They then lock onto VDAC. VDAC is a voltage-dependent anion channel. And what they're doing here is they're solidifying the outer mitochondrial membrane so it will not break. Because normally when a cell is having a lack of energy, the mitochondria will sort of break open through what's called the permeability transition pore, and the cell will die. All right, that's called going into apoptosis, programmed cell death when it happens slowly, necrosis if it happens rapidly. But what I'm trying to say here is there is a primitive pathway that these cells that survive hypoxia, they transform themselves into becoming like an anaerobic bacteria, like a prokaryote. And that's how they survive. And they shut off the programmed cell death pathway by HK2 lining up and attaching to VDAC and the mitochondria. Okay, and they're also right there, whatever little ATP is coming out of Krebs cycle, which can still run without oxygen, they're going to suck up that ATP and use it to pull more glucose into the cell. So this is it. This is the primo thing that happens in cancer. And what I'm also saying here, this is not some random mutation. This is sort of an entire cell pathway of survival in hypoxic conditions. So here's the big thing you'll see if you want to understand the overall structure of cancer. Phase 1 is initiation. Phase 2 is tumor promotion. Phase 3 is invasion, spread to the nodes, nodal metastases. We just call them METs. Hematogenous metastases, hematogenous METs. All right, so what causes initiation? The main cause is hypoxia. And this is the metabolic theory of cancer, MTC. And Otto Warburg is the first one who figured this out. Okay, and this is the cancer reverting to a primitive pathway to anaerobic metabolism. You can call it atavistic, you can call it vestigial, you can call it reverting to a primitive type, but that's what's happening. Now, what is the other attempted explanation? Something called the somatic mutation theory, SMT. And that's what's in all the textbooks. That is what has sort of been agreed upon for many years by most people who work with cancer patients. And in my opinion, after studying it very extensively, I think it's wrong. I think it's flat out wrong. I think it's been refuted. But you'll still find that in all the books. And this is the idea that mutagenic chemicals and infections like viruses will cause mutations. All right. Now here, what causes tumor promotion? Tumor promotion, estrogenic chemicals stimulate proliferation of estrogen-sensitive things like the breast ductal tissue, the uterus, the prostate. Iron also promotes tumor. Insulin elevated promotes cancer. That is not well known. That's why you don't want to eat high fat, because it causes insulin resistance And then insulin resistance, a tumor promoter. We talked about how insulin causes an increase in ILGF, insulin-like growth factor, tumor promoter. They increase mTOR. mTOR is mammalian targeted rapamycin, also called mechanistic targeted rapamycin. And what it is a nutrient sensing pathway. It's like a contractor getting ready to build a building. And the contractor, before he can build the building, he's got to make sure he's got all the parts. So the rate limiting step is, is there enough leucine available? Leucine is an amino acid. Guess what? T. Colin Campbell, the guy deserves a Nobel Prize, but he's not even in the books, and he never will be. Why? Because this is not conventional thinking, but it's correct thinking, all right? So animal protein has a different amino acid composition than does plant protein. Animal protein has much more leucine, much more lysine, much more methionine, and in particular, it's the leucine which activates mTOR. And then mTOR tells that cell to replicate, plus it activates a couple other things that cause increased cancer, increased tumor growth, all right? Immune suppression also happens. We talked about that from the lactic acid primarily being pumped into the tumor microenvironment. All right, now what about invasion of cancer? We get increased HIF, that's hypoxia-inducible factor. By the way, mTOR will increase HIF. HIF increases VEGF, vascular endothelial growth factor, and you also get increased MMPs, matrix metalloproteinases. Okay, you don't need to know all those words. All you need to know is hypoxia is bad. Animal protein is bad. These are all things that cause cancer to progress. And by the way, this is the money area right here. This is one of the most important slides in this talk. Tumor promotion, tumor promotion. You don't want it. You can't change having been exposed to some chemical, who knows when, 10, 20, 30 years ago. You can't change that. It already happened. But you can control this. You can control tumor promotion to a very large extent by avoiding all these estrogenic chemicals, by avoiding excess iron, by avoiding dietary fat that's going to drive up your insulin, hyperinsulinemia, and then your ILGF, okay? And you activate your mTOR, okay? You can avoid things that suppress your immune system to a large extent. Okay, so, and this invasion of cancer, we talk about some of those things, and they're similar. We're going to talk about what activates platelets. Platelets are, you don't want your platelets activated for no reason, because they can increase your risk of metastases. We'll talk about that in a sec. And animal protein in general in your diet, it causes increased inflammation. All the, xenocylitis, postprandial lipotoxemia, all that stuff. Okay. All right, now here's a bigger picture. Again, this is good to know. The normal cell is a worker. Imagine you're a liver cell. Okay, a liver cell in a human, it's got a lot of work to do. It has to detoxify things in the blood. It has to excrete estrogen. It has to make the bile, excrete the bile. It has to maintain a blood glucose level, so it has to sense the blood glucose, has to maintain a glycogen storage. It has to run gluconeogenesis. Okay, it's got a lot of work to do. That takes tons and tons of ATP. So the normal cell is a worker. Okay, it makes tons of ATP. It's busy, 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 busy. All right, cancer's not like that. Cancer, like we said, screw this job, take this paycheck and shove it. I'm not working here no more. I'm going to go get an apartment. All right. So the cancer cell, it doesn't care that much about making ATP. It'll make some ATP, but it don't really care too much. It gets a lot. It just needs to take in more glucose because it's going to run this anaerobic-like metabolism. It's going to take its pyruvate, convert it to lactate, like lactic acid. And I should have drawn it in this picture. It simultaneously pumps out protons, which are acid particles, to make its tumor microenvironment called the tumor milieu, to make it more acidic. Because that acidity pumped around the cancer, it suppresses all the immune cells, and then they can't touch it. Okay. Like the MC Hammer song, can't touch this, man. When it's surrounded by lactic acid, it becomes immortal. Okay, it also has telomerase enzyme, so it can replicate immortally like a stem cell. We'll talk about that in a moment. But what I wanted to talk about cancer metabolism, it has a different priority. Its priority is not work. Like we said, it don't care about working. It cares about replicating itself. Like a bacteria, it just wants to replicate itself. So it has to, in order to replicate oneself as a cell, you have to double yourself first. So you have to make copies of all your proteins, copy of all your nucleic acids, your DNA. In a human cell, there are 3.3 billion pairs of DNA, 3.3 billion base pairs. That means you got to make 6.6 billion nucleotides for your DNA, all right? So that's a ton of biosynthesis. So that's what it's all about, growth and biosynthesis. So its priority is to go down this direction. Okay, and it's also going to run this thing called the pentose phosphate pathway. That's where it makes its ribose for the skeletons of the DNA. It also makes its NADPH, which is really important for maintaining its antioxidant status. It protects itself with antioxidants. So in a cancer tumor, there is tons of oxidants, bad things. We're going to talk about that, like hydrogen peroxide. But the cancer protects itself. It's like all its neighbors is like, screw you guys, and it showers them with H2O2, hydrogen peroxide. But it protects itself by running tons of this NADPH, making it's reduced glutathione, which is typically listed as GSH. All right, so cancer is behaving like a bacteria. And here's like the life cycle of a bacteria on a culture plate. It's dormant, just sitting around. All of a sudden, food becomes available. Zoom, it grows as fast as it can, replicates, hits a plateau phase, then it runs out of resources and it dies. Okay, so cancer, in a sense, it's like a genius at replicating itself and growing, but it's like an idiot in a sense too, because it just kills a person, and then it's got nowhere to go. All right, but that's what it does. It's a primitive thing. Okay, now I'm going to talk a little about my mom. I'm actually dedicating this talk to my mother, and there's something. The reason why I'm doing this, and I think it'll be beneficial to the audience, is she was told when she was diagnosed with colon cancer, she was told she's only going to live about 2 years, 3 at the most if she's lucky. And she lived 11 years. And basically, she did everything right. But I'm an idiot. I didn't know about this nutrition and diet and lifestyle stuff. I didn't know. I was young. I was in med school. And I just figured at that time, send her to the specialist. Okay. So she was born in Puerto Rico. She actually won the queen of her little town when she was young. That's her when she was young. Here's a picture of her family. It's kind of an interesting story. And I'm going to tell you something weird about my mom. She grew up in a barn. And I'm not joking. She grew up in a barn, like a barn animal, like a farm animal. And now, why would I say that? Here is her mom. And then here is her dad. And her dad was known as the genius of the island. They said he was the smartest man in all of Puerto Rico. And I think there might be true, because he was a merchant marine. On a sailing boat, he would travel between all the islands of Puerto Rico and all the Caribbean islands. So one day, his wife found out he had a family on another island, and she just went apeshit bananas crazy. And I don't know all the details of what happened, but it wasn't good. And he never came back. And the family became really poor. It's kind of like a Tiger Woods moment, So the family then had no money, and they had to go live with a cousin who owned a farm. They had to live in a barn. So that's my mom. And, she ended up getting a master's degree at the University of Chicago. The oldest brother was very nice, Eddie. He went and, to help the family, joined the army, and he, gave all his money to the family, so he didn't get a chance to get as educated because of that, but it was very generous of him. Here's his sister, Irma, and she was like a genius. She graduated first in her medical school class. As a matter of fact, she was teaching physics, and then her husband cheated on her. She got pissed off. So she said, I'm going to med school. And then she had her kids go live with her brothers and sisters. So one of her sons lived with us. He's like my older brother. But that's kind of a typical thing of my mom. My mom was always adopting people. Any friend of the family or person in need that she was friends with, they would live at our house as long as they needed to. And that was a routine thing at our house. My mom she's like a modern saint taking care of people. Here's another brother. He's an anesthesiologist. He was a mathematician. Then he became an accountant. He was better for making money. She's a PhD in nutrition. So what I'm trying to say is, and the other brother was a doctor, growing up in a barn without 10 cents, and they were able to get really educated, and they're super nice. Puerto Ricans are really funny. They're very extroverted and gregarious and funny and talkative. There's a lot of difference between all the Hispanic populations. Most people don't know that, but man, Puerto Ricans are a lot of fun. So it's sort of like they're really smart, and I'm really close to them emotionally. My father, though, is intellectual coach. This is my dad with my mom. The Irish, it's a more bookish, history. A lot of Irish writers and stuff. So it's more academic, reading books, talking books with my dad. But Puerto Rican family, they're really smart. So anyways, that's my Puerto Rican family background, and it's gonna come up. So here's my parents when I got married. It's nice. Here's my great grandfather on my Irish side. He was 9-time national champion. Look at the muscles on his legs, riding a bicycle. And these are my brothers. So the point I'm saying is, my mom's sister was she was a PhD in nutrition. So my mom was actually reasonably good for those days. She'd always have fruits and vegetables on the kitchen table. So my brothers and me, he was a state champion wrestler. And here's an interesting story about my younger brother. He was state champion wrestler, Greco-Roman freestyle in high school. Then in college, everybody expected to be an All-American, maybe national champion. And he didn't do much in college. What happened? Well, it turns out that, he ate a lot of junk food. When he's in his 40s, he became vegetarian. He kept on wrestling and doing martial arts, jiu-jitsu and all that stuff. And so once he became a vegetarian in his 40s, he had exercise-induced asthma. So, those Iowa guys, they don't have the best technique, but they're in such great shape. They wear you down and kick your butt in the third period. So he couldn't beat those guys in college. But once he went vegetarian in his 40s, he became a 3-time world champion as an athlete. I was a really good athlete too, but I injured my clavicle. My brother was a really good football player. He's a lot bigger than he looks in this picture. And he hurt his knee. And, my brothers were really good looking. I would never, if I liked a girl, I would never let her see my brother before I figured out if I really wanted to stay with her or not. Because once she saw my brother, go, oh, your brother's so gorgeous. And that was it, I lose my girlfriend. Okay, so now we're going to talk about cancer again. We're going to come back to my mother. I just wanted to introduce you to her. So when we talk about her cancer, you'll know who she is. All right, now here we're going to talk about cancer screening. Now, cancer screening is a difficult thing to talk about because people love it. In my experience, anybody who doesn't know cancer screening or anybody who makes money off it, they all love it. I got 30 years experience with it. And I'm going to tell you, it's a little bit like two guys standing on top of these buildings at the store and dropping a big net on all these people walking by. and turning them into patients, okay? But I can tell you this, I don't even talk about this with patients anymore because people get upset. I know tons of people love cancer screening. I think it's going to increase, okay? But I'm just letting you know there are real problems with it. So I'm going to read to you something from a book. This is from a book by Fyodor Dostoevsky called Brothers Karamazov, and this is from the Grand Inquisitor. It'll seem a little strange at first, but what I'm telling you, trust me, it is a psychology of screening. Okay, so here comes the Grand Inquisitor chapter. And the Grand Inquisitor is talking to Jesus Christo, and he says, "Why hast thou come to hinder us?" Jesus Christo came back to the earth around the time of the Spanish Inquisition, and the Grand Inquisitor is pissed off, has him in prison, and he says to him, "Why hast thou come to hinder us? For thou hast come to hinder us, and thou knowest that. But dost thou know what will be tomorrow? I know not who thou art, and care not to know whether it is thou or only a semblance of him. But tomorrow I shall condemn thee and burn thee at the stake as the worst of heretics. And the very people who have today kissed thy feet, tomorrow at the faintest sign from me will rush to heap up the embers of thy fire. Knowest thou that? For 15 centuries we have wrestled with thy freedom, but now it is ended and over for good. Today men are more persuaded than ever that they have perfect freedom, yet they have brought their freedom to us and laid it humbly at our feet. Dost thou know that the ages will pass, and humanity will proclaim by the lips of their sages that there is no sin, there is only hunger, and we alone shall feed them in thy name, declaring falsely that is in thy name, and in the end they will lay their freedom at our feet and say to us, make us your slaves, but feed us. Okay, Grand Inquisitor Fyodor Dostoevsky from the 1800s. So what am I saying? What I'm saying is there's this mentality that people are hopeless and stupid and can't do anything for themselves, that humans are just talking primates who must be guided by the experts, often in an authoritarian way. And what I'm saying is, while I am part beast, I am also part divine, created in the image of God, a sovereign individual capable of learning, who can shape his own destiny. I am a free man. I have climbed out of Plato's cave. Most people are passive and weak and want someone else to take care of them. They want to stay in Plato's cave. They like going to the clinics and hope they'll be saved. And what I'm saying is, you get much better results if you learn how to take care of yourself and you put that effort in, than expecting somebody else to take you some system that's going to have to run you through like a factory. Okay, that is the smart move. So what I'm saying is, instead of screening for myself, I make my risk so low that my pretest probability is so low to screen would be ridiculous. That's where I want to be. Okay, hardly anyone does this, and believe me, people don't get this. Now, here's something you got to know about cancer if you want to have an intelligent conversation about cancer. This idea of categories comes from George Corral and the old guy from the Cleveland Clinic and Gilbert Welch. Okay, you can think of cancer as 3 categories. All right, the first category is the vulture, and the vulture is bad news. Well, first of all, this picture is, imagine you're a farmer and you got like 100 square miles of farmland. You got the animals penned up in the center, and then there's a fence around the perimeter of the farm. Well, guess what? If the vulture breaks out, he's gone. He's going to fly over the fence and kill the patient before anybody can do anything. The good news about vultures is they're very, very, very rare. But if a vulture breaks out of his enclosure, he's gone. Okay, that's it. Person's going to die. And what I mean by that is, if you try to screen, the vulture will escape and kill the patient before you get to the next screening interval. Screening is not going to help you with a vulture. All right. Now, the next type of cancer is a rabbit. And now everybody thinks that most cancers are rabbit. When they hear the word cancer, they think rabbit. Okay, now the rabbit is going to make a run for the fence, but you got a chance to get the rabbit. Once he gets to the fence, he's got to dig underneath the fence. You got a chance to catch that rabbit, throw a net on him, bring him back to the enclosure. And that's kind of what people think. That is the classic story of cancer. A rabbit's on the run, you got to catch him. Okay, but here's reality. Most cancers are turtles. And most cancers, a turtle, you really almost better just leave the turtle alone. Okay, turtle's not going to kill you. You could take all day. You can go out to the movies, come back later. The turtle have barely made any progress towards that fence. All right, that's important to know. So vultures, rabbits, and turtles. So cancer screening, like I said, I don't talk about it, people, because patients love cancer screening. And, tons of private practice hospitals, they make millions, tons of money off of this. All right. So I think it's going to continue to increase. All right. I told you it's like a net being thrown over people. It turns all these people into patients. And you can give them the first test free. Let's say your private practice hospital, give them the first test free. Then you can bill them for the follow-ups. It's easy to get them to show up. Everybody gets so scared when they hear the C word for cancer. Okay, so what I'm trying to say here is, when you start getting into the details, the lead length bias, false positives, treatment side effects, the net result is it really doesn't do much good. All right. And once you go for one screening, you could be trapped easily into 5 years of follow-up and lose a lot of money. And like, for example, look at prostate. I've seen lots of guys, lots of men walking around, normal guys, 70, 80 years old. If you did a biopsy on them, they would have prostate cancer, and it's probably a turtle, and it's better not to know. Once they get diagnosed with cancer, they freak out. Going by the standard of care, the surgeon is pretty much obligated to take out their prostate. And so the guy quite often ends up impotent and incontinent. And it might cost him a lot of money. It might be bankrupt. So what I'm trying to say is, was that intelligent to make yourself impotent and incontinent? Why not just lower your risk and not screen? Are you taking a chance you might miss something? Yes, but you're taking a chance either way. All right. And this applies to a lot of things. None of these guys have read Ornish's papers on low-grade prostate cancer and the vegetarian diet. Okay. So anyways, I'll let people study that for their own if they want, but I'm just letting you know it's kind of impulsive. Be careful about impulsive behavior. Oh, I think I'm going to go get screened for prostate cancer or check my PSA. Me personally, I make my risk low. I don't want to know my PSA. I'm not worried about it. Okay, is cancer a genetic disease or a metabolic disease? Like we talked about, the metabolic theory of cancer makes a ton more sense. And they did something called the TGCA project, the Cancer Genome Atlas project. Those, by the way, are the names of the DNA base pairs there, TGCA. And what they found was there was no consistent pattern of mutations. The genetic theory of cancer is absurd. This is Thomas Seyfried. He's a real famous guy for talking about the metabolic theory of cancer. We'll come back to him. And he actually did some good research and he has some good things to say. I disagree with him on his recommendations. He recommends keto diet, which I think is a big mistake. But the guy did some really good research and knows a lot about metabolic theory of cancer. He's got YouTube videos on that subject as well, and he wrote the book about it. Okay, the Travis Christofferson book on tripping over the truth regarding refutation of the Cancer Genome Atlas is also quite good. And so what I'm trying to say is the thing that makes the most sense is hypoxia is the most common cause of cancer, transforming a cell into anaerobic. You can call it aerobic because oxygen might be present in metabolism, but it's transformed into behaving like an anaerobic bacteria. Trust me, if you work around that, you'll be able to make sense of tons and tons of things in cancer. Now, the mutation theory is bogus because there's no consistent pattern of mutations, and you're not just getting one mutation to change these cells. You're getting hundreds and hundreds, okay? And so let me explain something. A mutation is a little bit like putting a scratch on an audio CD, all right? It doesn't do good things typically, almost ever, all right? But a single mutation is like accepting your spouse's last name as part of your own. Yes, it's a change, but it's not that big a deal. Cancer is like changing your entire name completely, getting plastic surgery to change the appearance of your face and your fingerprints, conquering a Caribbean island, and then enslaving all the people. It's a big deal. Tons of things are happening. One little bogus mutation isn't cancer. It's hundreds of things change in a cell. And it's a transformation to a vestigial, primitive throwback. It's like the electricity went out and you got to turn on the backup generators and run this glycolysis, out the wazoo. 100 times more glycolysis you're going to run than a normal cell. Okay, you're also sucking up glutamate from below and running that through Krebs cycle. You can make 1 ATP off of the Krebs cycle itself. So making stuff off just those reactions, that's called substrate level phosphorylation to run glycolysis or Krebs cycle, only for ATP production. So the goal of the bacteria is replicate, replicate, replicate. And so keto for cancer, I'll show you why I don't believe it. And the big thing we're going to talk about, we already talked about Warburg effect. I'm going to teach you guys about the reverse Warburg effect. And that's an interesting thing. Just wait till you see that. Okay, here's Seyfried. It's his article. If you want to read his article for free, cancer is a mitochondrial metabolic disease, a bright guy. Watch his lectures. It'll make sense. Here's one of Seyfried's information, and this is very interesting. A normal cell, here's the DNA, here's the mitochondria. It replicates, copies itself. Everything looks the same. Good. Cancer, everything kind of here in red or maroon, if you will, replicates itself. Okay, just what you expect. Here's where it gets interesting. If the DNA theory, the mutation theory were correct, when you take the nucleus of a cell, these are called hybrid cells. Sometimes we call them hybrids for cell and hybrid. You take the DNA of a cancer cell, cancer nucleus, and then you have that cell replicate, it'll be a normal cell. So what's the point? Whatever's causing cancer, it ain't in the nucleus, okay? It's coming from the cytoplasm and the mitochondria. Now you take another cell here, and this is a cell with a normal nucleus. So it's got normal DNA, but it's got the mitochondria from a cancer cell, and it's got cytoplasm from a cancer cell. You replicate that cell, you get cancer. Okay, I should have made the cytoplasm maroon. I screwed this up. But you get the point. Whatever is causing cancer, it's related to problems with the mitochondria and the cytoplasm. It is not the DNA and the nucleus. That's an important point. All right, now here's a tumor. Let's see how I'm doing for time here. We'll go a lot of slides here. What time is it? Okay, 13:24. I got to go a little faster. But here's the cancer. Here's the stem cells. And here's one of the problems with chemo. Chemo, they'll talk about getting a response. And the patient thinks that means cure. No, to have a good response does not mean you're cured. It means the tumor has shrunk down in size. And yes, that's good. That's encouraging. But quite often, the chemo is not able to cure the cancer stem cells. It is for some cancers, like testicular cancer and some other cancers. But quite often, for a lot of the common cancers, it can't kill these stem cells. And that's why the cancer will come back later when these start replicating. They get out of control, and they're often resistant. These stem cells, they're often resistant. They have an ability to pump out the chemo. They're hiding in this big tumor, and they're relatively hypoxic down deep in the tumor, and they're so-called hypoxic niche. And the chemo doesn't even get to them. Okay, and they're only 1% of the cells in the tumor originally, or less. And you can't have chemo nonstop because it's going to kill the patient from its other side effects and suppression of the immune system. You need that immune system to remove these cancer cells. And that's one of the fundamental problems with it. It's from this article here. Okay, this basically shows all the things that cancer does. And what I'm showing here, I added this green highlighting, green writing myself. Oh, and here it's just summarizing that same thing from this paper right here below, targeting cancer stem cells. Cancer stem cells are resistant to these therapies. They divide slowly, so you can't kill them with the fast dividing stuff. They have good capacity for DNA repair, so they can fix themselves. And they have multiple drug resistance, membrane transporters. They pump the chemo out of themselves so they don't get killed by it. That's why it's very hard to kill the stem cells. That's why it's hard to kill a lot of the common tumors, in particular with chemo. You just can't do it quite often. That's a problem. And you can only go so high or so often on the dose. Whereas you can eat fruits and vegetables and do all this other stuff, reduce your iron every single day. It's a 24/7 approach. And here's all the things that cancer does. It does a lot of bad things in order to grow and kill the patient. And you can do all kinds of things. You want to decrease angiogenesis, decrease hypoxia, avoid fat, avoid sodium, avoid tobacco, avoid carbon monoxide, avoid mitochondrial toxins. You want to, avoid stress so you get less immunosuppression. Okay, you can do a whole bunch of things. We'll talk about that more later. But the point I'm making is these cheap strategies, you can do them 24/7 and they have a protective effect. All right. Potatoes are super low in leucine. So you eat meat, you're going to get tons of leucine. Leucine activates mTOR. Leucine causes increased risk of diabetes. Diabetes is a disaster. Typical diabetic patient, they're nice, but they're so clueless and ignorant. They're always like, my diabetes is under control. You talk to their spouse, his diabetes is under control. Yeah, right. You don't even understand what a disaster diabetes is. You're going to have increased mTOR. You're going to have increased insulin-like growth factor, increased insulin. All those things increase the risk of tumor progression and the patient dying. Okay, potatoes are super low in leucine. That's good news. That's the kind of thing you want. Okay, metabolic roles of AMPK. So that's AMP activated protein kinase. And all this means is when you exercise a lot, your cell has this AMPK pathway that senses the energy level. And you're going to be low in energy level after you've exercised. And that's good. Because basically mTOR means high energy level, tons of food and proteins available. Let's replicate, time to grow, time to party. Okay, AMPK is the opposite. It says this person just, ran 3 miles, they're exhausted. We're very low on energy. AMP is like adenosine monophosphate instead of ATP, adenosine triphosphate. It means low energy in the cell. And it says now is not a good time to grow. We've got hardly any energy. We need to just sort of recover from our exercise workout. So exercise lowers mTOR. Did you hear that? That is big news. Exercise lowers mTOR through this AMPK pathway. One of the things I've noticed, lots of these vegan survivors, we're going to talk about Ruth Heidrich, Janet Murray Wakeland, they both wrote books about surviving metastatic breast cancer. They run like crazy. They run marathons. I've known some other breast cancer patients who are run for exercise. They're energetic, active people. And what I'm saying is they often get the best outcomes. I've seen other guys survive pancreatic cancer running marathons, all right? Exercise is your friend. It does a lot of other good things too. We'll talk about that. It gets your lymphatic tissue to flow. And when your lymphatic flows around, you don't have a heart. You have a heart connected to your arteries and veins. You don't have a heart connected to your lymphatics. The lymphatics are pumped by muscle contraction, just like your legs. Muscles squeeze your calf, squeeze your leg veins, and then there's a valve system. Well, there are parallel to all your veins. There's lymphatic vessels, and they are pumped by your muscles. All right. Now here's mTOR. mTOR, this thing of badness, activating hypoxia-inducible factor, all these things, more glucose transporters at the cell membrane, more hexose kinase 2, sucking in glucose like a vacuum into the cancer cell. All right, so mTOR helps cancer grow. That's why you don't want mTOR. And you minimize mTOR by avoiding meat, so you lower your leucine, and avoiding high fat, so you lower your insulin, because insulin and ILGF also activates mTOR. That's what you want to do. And you exercise, that'll lower mTOR. So there's a lot you can do to lower mTOR. And man, if you could slow down that cancer doubling rate just by half, maybe by 75%, you got plenty of time to enjoy your life. Okay, T. Colin Campbell, he's like the hero of nutrition. He did like the world famous great research showing that increased animal protein intake will cause increased cancer growth. His book, The China Study, is one of the greatest nutrition books ever written. And what did T. Colin Campbell say? Cancer is far more affected by tumor promoters than by carcinogen. That's what I told you. Here is where you have a good chance to win the game. Here's where I would try to win the game if I was trying to survive cancer as long as possible by minimizing tumor promoters. And I already minimized tumor promoters. My whole diet and lifestyle, the optimal healthy diet and lifestyle, minimizes tumor promoters. There's a few little tweaks I would do beyond what I'm already doing now if I was actually diagnosed with cancer. Okay, TCC also believes humans should eat 0 animal products and 0 oils. I agree with that, because if you plot cancer, it goes right through the 0 line, meaning that there's no safe amount. Certainly, though, when you get above 5% animal protein, the risk of cancer goes up a lot. All right. I'm going to actually talk about one little thing about T. Colin Campbell when we get a little further along that's going to come up again. I have one thing that I do question about his theory. And the guy's brilliant. He deserves a Nobel Prize. He'll never get it. He's not even in the textbook. They tried to fire him from Cornell. So that's what he gets. That's what he gets for being a genius. Okay. And that's what you're going to see. That comes up a lot, unfortunately. Western diet females have 5 times more breast cancer than these plant-eating women in China. All right. That's a big difference. Okay, Otto Warburg, MD, this guy won Nobel Prize 1931, figured out the mechanism of cancer. Hypoxia causes injury to the mitochondria. After the mitochondria are injured, they switch over to the fermentation, meaning they just switch over to energy production, primarily from glycolysis. That is called the Warburg effect. You need to know Warburg effect. That is super important to know. Okay, all normal mammal cells have an absolute requirement for oxygen, but cancer cells can live without oxygen. This is a rule without exception. Otto Warburg. He was considered the greatest biochemist in the world in the 1900s. All right. And he was very meticulous and precise with his measurements. All right. Cancer cells make about the same amount of energy as a regular cell, but they make it from glycolysis and Krebs cycle, making ATPs. All right. So Warburg himself said, if you want to, avoid cancer, keep your blood flowing well, even keep your tissues well oxygenated. All right. Cancer acidity. We talked about that, pumping protons out into the tumor microenvironment, and that makes everything acidic, and that suppresses all your immune cells. So let's say you got a lung cancer here, right? What normally would happen is your immune cells would find the cancer, and then they would take the cancer, they would like kill a cancer cell, and they would take parts of it to the lymph node. When they get to the lymph node, it's like calling up all the reserves. Hey, you guys, we got cancer in the lung. Let's make whatever we can make to fight the cancer. Activate all the lymphocytes. Okay, so then the lymphocytes would go into clonal proliferation and make as many lymphocytes as possible that were targeted to that cancer. They go back to the lung and they would try to remove the lung from your body. But what the lung is doing to prevent that is it's pumping out tons of lactic acid around itself and protons to acidify its microenvironment. And when it can do that, it'll suppress all these immune cells and they can't kill the cancer. And that happens with all these different cancers. So that's what I'm trying to say is you need your immune system functioning well. All right. Okay, this is just showing this like a force field. They call it here in this article. Here's the article right up here, Seminars in Cancer Biology. Low pH in the tumor microenvironment works like a global protection shield for cancer cells. All right. All right. All right. What about the cancer milieu? So what the cancer cell is doing is it starves all the cells around it because it hypertrophies. It increases the number of insulin-like growth factor receptors on its membrane, glucose type 1 transporters to suck in more glucose, transferrin receptors to suck in more iron, glutamine transporters to suck in more glutamine, the amino acid, pumps out the acid to create an acidotic milieu that suppresses all the cells around it and inhibits all the immune cells. Cancer is a badass, man. That's why it grows and it kills people. Anything that contributes to metabolic acidosis, like the excessive amounts of sulfur groups in animal protein is more methionine and cysteine. Those are the sulfur-containing amino acids, and those in their metabolism, they're partially degraded to sulfuric acid, causes the low-grade metabolic acidosis. That favors cancer. When you take lots of dietary sodium chloride, salt, the chloride displaces bicarbonate ions from the blood, and that causes a low-grade metabolic acidosis. That favors cancer. You don't want that. Okay. We talked about hypoxia favors cancer. We'll get into some more of these other things. Angiogenesis means making new blood vessels to help the cancer grow. By not releasing CO2 as a waste product, it prevents vasodilation. Again, this hypoxic microenvironment favors the cancer cell. And it ends up trying to, in a sense, heal itself a little bit like wound healing. And there's certain overlaps between, like I said, cancer becoming like an anaerobic bacteria. cancer becoming like a healing wound. And there's more tricks that cancer has up its sleeve. Okay, pancreatic cancer. Now, pancreatic cancer is one of the worst cancers. Most of them are ductal pancreatic cancers, PDAs, pancreatic ductal adenocarcinoma. Most of them are in the pancreatic head. This is what Steve Jobs died from, actually, an islet cell pancreatic cancer, one of the less aggressive pancreatic cancer. Other famous people that have died from it: Patrick Swayze, Luciano Pavarotti, okay, one of the greatest opera singers that ever lived. Okay, he was a guy. Swayze was in Dirty Dancing. That was a really good movie many years ago. All right, what are the risk factors? Tobacco and alcohol. Tobacco and alcohol are a risk factor for almost every cancer. Being fat, that's a risk factor for almost every cancer. Eating a lot of red meat is a risk factor for most cancers. Inadequate eating of fat and vegetables. And from this, you can kind of see some things you should do. Don't smoke, don't drink, don't be fat, don't eat meat, eat more fruits and vegetables, okay? Chronic pancreatitis is an inflammation of the pancreas. Diabetes, we talk about that. Diabetes increases almost tons of different cancers. It's like creating cancer metabolism throughout your body. There are some genetic mutations associated with it. Usually it happens in older people. Older people usually have less function of their immune system, and also they're more prone to atherosclerosis and tissue hypoxia. Okay, survival is really poor. In 5 years, it's only about 5%. Best chance typically is if a person can get surgical resection, if they don't have obvious macroscopic mets and they're fortunate enough to respond well to the chemo. So that's about the best chance, even with surgery and everything, to get a 20% survival at 5 years. So that's pretty poor. They often early metastasize to the liver, peripancreatic lymph nodes, and elsewhere. Okay. McDougall has a nice lecture on Steve Jobs. If you're curious, you can watch that on the internet on YouTube. Now, this guy, Stop Feeding Your Cancer, John Kelly, he actually took a bunch of his patients and ran them his urine. He's an Irish doctor, and he just let them get conventional therapy. But on top of that, he had them go low fat. Well, he didn't have them go low fat vegan. He had them go vegetarian. He still allowed them to eat fish, which, he didn't know any better, but it was pretty bold of him to try doing this. He wrote a book about it, Stop Feeding Your Cancer. And he noticed that most of his patients, for most of their cancers, got excellent results, which they often attributed to the surgery and chemo, and perhaps that was the case in some. But when they stopped their diet, they would crash and burn. Relapsed cancer often die. But one of the things he noticed that all 4 of his pancreas cancer patients did poorly. All right, they died relatively quickly despite moving towards a vegetarian diet. But here's what I'm going to tell you: I have a problem with that, and here's why. Because I don't think this guy John Kelly was strict enough. He let them eat fish. People eat fish. They're most of the time eating fried fish. He let them eat oil in their food. He didn't tell them to reduce their sodium, their caffeine, their alcohol, their tobacco. Maybe he did tobacco, but I don't specifically know that. I don't recall that from the book or from seeing his video. So what am I saying is a person could do more. Restrict all this stuff and some other tricks I'll talk about later. He thought it might be because the pancreas has digestive enzymes which potentially can auto-digest, but I don't know if I buy that. That was just his theory. I haven't read that anywhere else. I read a couple articles on why does pancreas cancer be so difficult to treat. It creates a desmoplastic, meaning fibrotic reaction around itself with scar tissue, so it's very poorly vascularized, profoundly hypoxic, meaning that the chemo can't get deep into that, find those stem cells in their little niche of hypoxia, so it's not going to respond well to the chemo. And then it metastasized early, so it's all over the place. That's partly why it tends to be tough to treat it. But what am I trying to say? No one has tried this yet. We're looking at uncharted territory. There's no money in all this diet and exercise and all this stuff. There's a guy by the name of Ron Weiss. He's a physician, a bright guy, and his father had pancreatic cancer, again, unresectable diagnosis. And he went on a macrobiotic diet, a vegetarian type of diet. And his father did very well for a long time. Okay, he's got videos online. You can see him talking about that. I saw this video about a guy named Phil Kent, a survivor, their YouTube internet videos. And he ran a bunch of marathons. He's pretty sick, though. He had a pancreatic surgery, partial pancreatectomy, his body and tail cancer. And then he also got mets in the liver, had a partial hepatectomy, part of the liver taken out, etc. But what I'm still saying is what I would consider, pulling out all the stops, doing everything you could. That has not been tried yet. And maybe it would work. I don't know. Pancreatic cancer, why is it so hard to treat? If you want to start reading about the subject, this was the best of the articles I came across. And it's basically going to say the things that I just talked about, but it'll get you started in the literature if you want that. Okay, cancer book. Here's a bunch of cancer books. So if somebody wants to read, these are things they could check out. And some people say, well, can you cure a disease with a book? You bet you can. Well, theoretically, you can learn enough to help yourself. Esselstyn's book, Prevent Reverse Heart Disease. Lots of people cure their coronary heart disease once they learn that. Chef AJ's book, Ultimate Secrets of Weight Loss. Once people read that, lots of people cure their obesity. That's the best obesity weight loss book. This is the best prevent heart disease book. High Blood Pressure Solution by Richard Moore. That's the best cure hypertension book. China Study by T. Colin Campbell. That's the best book. That's the first book I read about cancer. Actually, the first book I read about cancer, I would say, would be Radical Remission. The reason is Kelly Turner. She's got a tough mindset. This lady was like a social worker or something. She graduated from Harvard for undergrad. She's pretty smart. She don't know nutrition that well, but her heart's in the right place. She was working at one of these famous cancer centers, and she noticed a patient survived metastatic cancer. She's like, oh my God, that's great. How'd you do it? Tell me, tell me, tell me. But then no one else was interested. She's like, what the hell? How come you people aren't interested? And then she started looking up all these patients who had spontaneous remissions, radical remissions that totally out-survived their prognosis. And she's like, we should be studying these people. This should be a routine required class in medical school. And it isn't. So she wrote a book about it. So she does a great job of going through all the psychology of these cancer patients. And I think that will get you in the mindset of you have to do something. She had like 10 things that almost all the cancer patients do to get the best outcomes, improve their diet, improve their health, let go of their resentments, attitude of gratitude, have a purpose in life, all these things. And she goes through the psychology really good. She lets the patients talk too. She almost lets the patients talk too much. I listen to her audiobook and they go on and on and on. Some of this stuff, whatever works for them, good. Okay, but believe me, that book will go through all of it. Stop Feeding Your Cancer. I talked about that with John Kelly. This is a great book on the biochemistry, just understanding. So Christofferson and Seyfried, they do a good job of explaining the metabolic theory of cancer. They got videos to that effect as well, but they start losing it. They don't know enough about nutrition, in my opinion. They recommend keto for cancer, which I think is bogus, and I'll explain why. These are all other survivors of metastatic cancer and their books about it, and they're pretty good. And this guy talks about repurposed drugs. That's something I'm not that interested in, but I think that might be something that oncologists should do in the future. Okay, so if you're interested in the books, these will help you. And Koenig on Healing Power of Faith. Religion helps people live longer. It lowers their stress level. It does, something positive for them. Okay, Tripping Over the Truth by Christofferson. I talked about that. He goes into all the details of, how that hexokinase transition from hexokinase 1, a cytoplasm enzyme, to hexokinase 2 attached to the mitochondrial membrane, outer mitochondrial membrane, OMM. You're going to hear that again. That's the key thing that changes in cancer. And that's an important concept to get. It's basically turning on the backup generators, okay? And virtually every cancer cell had increased hexokinase 2. That's key. Attaches to the mitochondrial membrane, attaches to VDAC, voltage-dependent anion channel. And the point I'm telling you, these are metabolic changes. This is a metabolic transformation. This is not some isolated mutation. This is a cell saying, screw it. I'm done with aerobic metabolism. I'm done with being a worker as part of a multicellular organism. I'm going to live like a bacteria. I've seen them on TV. They have a great life. All they do is replicate, replicate, replicate. I'm going to get myself a new apartment. I'm not doing all this work like these liver cells. They're a bunch of chumps. They just work themselves into the ground. Who needs that? I'm going to replicate and move out. Okay, so cracking the cancer code. Okay, we talked about stem cells. Okay, why do cells get hypoxic? You've heard this in my other lectures, but basically, I'll just briefly, for the newbies, I'll explain a little bit of it. When you eat a lot of fat, it sticks your red blood cells together. RBC is about 7 microns diameter, capillary on average in the ballpark of 5 microns. So the red blood cell has to deform a little to get through. When the fat sticks it all together because of increased LDL cholesterol functioning like a bridging molecule, it then is hard to pump this thing here. It's like a big sandwich to pump that through a capillary. Blood pressure goes up and it's quite atherogenic. The higher the LDL cholesterol, the thicker the blood, the more atherosclerosis. Why does this happen? Because red cells have a negative charge on the outer surface. It's called a zeta potential. It's due to sialic acids. It repels other red blood cells. They're like two negatively charged magnets repel each other. Anything that's positively charged and big enough will stick them together, and that's LDL cholesterol will do that. IgM antibodies, that's why infections cause more clots. Fibrinogen, that's why stress causes more clots. Uric acid elevation will do it too. It comes from a high-fat diet with a lot of protein. Anyways, those are all bridging molecules. When you get this big sandwich of red blood cells all stuck together by the LDL cholesterol and whatnot, other bridging molecules, pressure goes up, you disrupt laminar flow. Laminar flow is like the side of your hand, a parabolic blood velocity profile. That's very atherogenic. Tends to cause atherosclerotic clots right here on the outer sidewall. So the pressure comes up under high pressure. The blood hits the median divider, spins around, turbulent flow and retrograde flow after bouncing off the median divider is sensed by the endothelial cells. They got little like hair cell-like extensions that sense direction of current. And when it's abnormal from excess turbulence and retrograde, they form a blood clot there. They shed their antithrombotic glycocalyx of heparan sulfate and whatnot, and they then express prothrombotic molecules, let's say VCAM, vascular cell adhesion molecule, for example, and clots form. That's atherosclerosis. Atherosclerosis is a blood clot. I got entire lectures on that. I know cholesterol is a component of it. That's cholesterol theory. Believe me, I did a fellowship at Harvard with the emphasis on vascular disease. I've been studying this stuff for decades. Atherosclerosis is a blood clot. You need to know that to make sense out of it. Okay, key thing to know about endothelial cells that makes nitric oxide. And that's a big thing that Esselstyn talks about. So you need to know that. And so anything that inhibits nitric oxide is going to lead to less vasodilation, meaning the vessels constricting, and also platelet aggregation, which is bad. So you don't want that. Excess dietary sodium is bad for your body. First of all, it inhibits endothelial nitric oxide synthase. They call it eNOS, E for endothelial, NOS, nitric oxide synthase. So it's going to inhibit eNOS. So you're not going to make nitric oxide adequately. That's bad. It's going to activate your platelets. That's bad. And it's also going to mess up your ion membrane gradients. So your cells are going to accumulate too much sodium inside themselves, which is going to decrease their ability to pump out calcium. It's a long story, but what I'm basically saying is every cell in your body gets sick when you eat too much sodium. It's not a good idea. And they become less able to protect themselves from cancer and other problems and infections. Okay. Okay. When you eat a lot of dietary fat, it thickens your blood, increased blood viscosity. They did these experiments going back to the 1950s. Peter Quo was a cardiologist in Pennsylvania, and he would check the patient's blood lipids every 30 minutes. And what he found at peak lipemia, he did this, there was this back in the days before IRB, Institutional Review Board, and he would do it with these known coronary artery angina chest pain patients, okay? And he would feed them this real high-fat meal, and during peak lipemia in the blood, high maximum fat in the blood, they'd all get chest pain. And then it would go away when the fat went away, okay? They don't get that when they eat a carbohydrate meal. And then that was part of the 1950s, 1960s. That was, oh, saturated fat is bad. So we'll switch to polyunsaturated, like all those oils with all the omega-6. And that was worse. It caused more prolonged thickening of the blood, sludging of the blood, and angina. It kept them their blood thick for so long. The worker said, screw this, man. We've been here all day. We're going home. You ain't paying us for overtime. So anyways, atherosclerotic plaque. It's like we said, we'll talk about it some other time. I got other lectures on that. I did a whole lecture with Chef AJ about that on atherosclerosis. The skeletal muscles, plasma membranes, they can't keep fat out. When you eat excessive amounts of dietary fat, it's getting across the plasma membrane in what's called like a flip-flop maneuver. The research study suggests that that's the case. It's not even, you can't even inhibit the plasma membrane transporters in this context. So high dietary fat causes insulin resistance and normal electron transport. This is the mitochondrial membrane. Electrons are passed down from complex 1. Then really they kind of skip complex 2. It's a long story, but they do. Primarily, they go to complex 3. Coenzyme Q transports them. Complex 4, oxygen accepts an electron, becomes water. And then you're pumping out protons at these stations. Here's the outer mitochondrial membrane into the intermembranous space. I'm going to show this all again, but just so you've heard it once, you'll hear it again, to create a gradient of protons. Then the proton is allowed to come back in to harvest the gradient, so to speak, and ADP is converted to ATP. So the bottom line is this is how we make energy. This is how we make ATP, the $20 bill of energy in the cell. And you need this system working, and excessive dietary fat screws it up and causes it to go backwards. When it goes backwards here, you start dropping electrons down into the oxygen in the mitochondrial matrix, the center of the mitochondria, and they become superoxide anions with an unpaired electron in their outer orbital shell. And normally this is scavenged. It is neutralized by superoxide dismutase, catalase, glutathione peroxidase. So anyways, normally this can be cured. It's not a big deal. A little bit of this happens all the time. But when it happens too often from excessive dietary fat, too many of these are formed, and they start undergoing other reactions, and they undergo something called lipid peroxidation, and they damage these mitochondrial membranes. And it's much worse if you have excessive iron present. That's why you don't want to be iron overloaded. Okay, then you also, because you backed up electron transport, you're also going to be backing up Krebs cycle. You're going to back up glycolysis. Those are the 3 major metabolic pathways, and you're going to produce a whole bunch of advanced glycation end products. They really come off primarily glyceraldehyde 3-phosphate. I have an entire lecture on this on my YouTube channel, Peter Rogers, MD. But just so you've seen this, okay, you're going to start making these methylglyoxal advanced glycation end products, and they go around binding to all kinds of things and trashing them. And then they even get taken up by this RAGE. RAGE is really the receptor for advanced glycation end products, and that will activate something else called NADPH oxidase NOx, and it'll produce more of them. You basically create this disaster, okay? All kinds of problems. Diabetics are much, much sicker than they realize. It's a metabolic disaster, okay? You get increased nuclear factor kappa B, and that causes all kinds of problems and increases cancer risk, increases inflammation. So these are all things that increase cancer. You're thickening your capillary basement membranes, causing more tissue hypoxia. You're creating inflammation. That's going to lead to more of a wound healing type of effect and more platelet aggregation. Platelet aggregation is going to hide your metastasizing cells. So what is an advanced glycation product? I talked about briefly the advanced glycation end products formed by reversing glycolysis as well as electron transport. But basically, you'll have a ring-shaped glucose in the blood, and it'll open up. This is called a Fisher projection. I remember it looks like a fishing line. It's a straight thing as opposed to a Hayworth projection over here, which is a ring. Okay, well, anyways, in an open chain form, the Fisher projection, it will then close, and then it'll open again, and it can go into what's called the alpha configuration with the hydroxyl group at the first carbon pointing down, or a beta configuration with the hydroxyl group pointing up. But the point is, during these transient moments where it opens up to switch into the other form, it can now bind to other things. All right, and this carbon can interact with a nitrogen side group on a protein, and this is what it means to glycate something. Glycate comes from the word sugar, and it'll stick to the other thing. It tends to be an irreversible bond connection. So that's why it's called advanced glycation end product, because it's irreversible. And it'll damage this protein wherever it is, like the capillary basement membrane. It will damage it. Okay, so here's an article, it goes into a lot more detail about advanced glycation end products and diabetes. And I just want you to get a sense of how common and how bad a disease diabetes is. So this author says, diabetes and its complications are becoming the world's most significant cause of morbidity and mortality, so suffering and death. So these authors are saying, this is a relatively recent article, 2014, diabetes is the world's most common cause of severe suffering and death. And it comes from eating high fat. That's why you hear all these people saying, oh, you need your good fats. BS, there are no good fats. Okay, I'm going to tell you that. We don't got time to go into all of it, but I'm going to tell you why. And I have really tried to answer that question. I agree with Nathan Pritikin. Nathan Pritikin said fat is bad. Okay, and there's a reason for that. Okay, so here is a normal capillary red blood cells cruising along. Looking at my time. Oh, I don't got much time. Okay, the red blood cells are cruising along. And then when you have diabetes, you get a thick capillary basement membrane. And what that means is normally a lot of oxygen is coming out of those cells off these RBCs. Can't get much oxygen out. Tissue hypoxia, increased cancer risk. Okay, here's the AGEs in food, advanced glycation end products. In meats and high-fat foods, there's tons of them. You go to these plain old starches, fruits, hardly any. That's what you want. You protect yourself by eating that way. And here I got an article with all the charts of them. A lot of people are telling you, oh, nuts are so healthy. Yeah, right. Look at all the advanced glycation end products and nuts. I wouldn't eat them. High-fat food like avocados got tons of them too. Okay, look at these seeds, 2,500, walnuts, 7,000. All right, now let's take a look at some healthy foods. These little, fruits and vegetables, you're looking like little double digits. A banana's got 9. That's nothing, okay, compared to 6,000, some of these other foods. You take a potato, you boil it, a little white potato, you got 17 advanced glycation end products. You make it into French fries, you're getting up to 1,500, 800. Forget about it. You don't ever eat fried food. And also the problem with the PUFAs is you end up with lipid peroxidation, the methylene bridge carbon between the double bonds. It's very prone to getting pulled off, and then you get all this cascade of reactions. I got separate lectures on all this stuff on my YouTube channel. Omegas, you get enough omega-3s and omega-6s just from eating plant foods. Dr. McDougall's talking about this. I got lectures on this. You don't need to be seeking them out, in my opinion. Here's the anatomy of a mitochondria. Inner matrix, inner mitochondrial membrane, intermembranous space. That's where the protons are pumped into. Outer mitochondrial membrane. These are just the pathways, glycolysis here, Krebs cycle here. F- in unfiltered water is a problem. It blocks these pathways, and that could make you sick. T concentrates it. I'm going a little fast, I know, because we don't got time. There's a whole bunch of things that inhibit mitochondrial function, and they all increase cancer risk. Anything that injures your mitochondria increases cancer risk. Their Krebs cycle will reverse in cancer patients because it's focused on biosynthesis rather than energy production. That's an interesting subject. There's entire books on Krebs cycle. I just read a good one by Nick Land called Transform. I thought it was pretty good. Okay, now here's the big point. Here's another academic orgasm. All right. This is called the reverse Warburg effect. This guy, Michael Lasanti, good paper here. Michael Lasanti, he's got a lecture on YouTube. You can check it out for free. Reverse Warburg effect. He calls his lecture something like metabolic coupling in cancer. Okay, because the cancer cell is coupled to the cancer-associated fibroblast, CAF, part of the tumor stroma. And the point is this: the cancer cell basically takes over the stromal cell. It uses hydrogen peroxide to force that cell to start functioning as its slave, in a sense, to make lactating ketone bodies. So that's my point. The cancer is feeding on ketone bodies, and that's why I don't think the ketogenic diet is a good idea for cancer. And Lasanti writes more about that. It feeds the cancer. And I'm going to tell you this, cancer is like the devil. Listen to what it does. It throws acid on the immune cells around it so they can't kill it. It weakens them. Then it uses a reactive oxygen species, typically hydrogen peroxide. It pumps it out. Here's the cancer cell. Pumps out H2O2 to like an electric cattle prod to enslave the fibroblast. And then it forces the fibroblast to commit suicide and start digesting itself. And then it takes those molecules that are broken down into their building blocks and it eats them like a cannibal. So that's what I'm telling you. Cancer is brutal, man. It's brutal. It's evil and bad. Okay. But we got a way to respond to it. Okay. Just like the devil exists in the world, so does God. He's on our side and we're going to fight cancer back. Okay. We're going to do everything we can to deprive it of oxygen, deprive it of iron. Okay. Deprive it of fat. All right. Once you drop oxygen delivery by 35%, you'll transform cells into cancer. And so, oh, here's another thing. I was talking about Dr. Esselstyn. Okay. Dr. Esselstyn deserves Nobel Prize, figured out how to create coronary disease. And he did that in the old days. Now, in the more recent times, he's talking about chewing on greens all day. And I noticed he's been hanging around that Nathan Bryan nitric oxide guy. And I go, is this truly a good idea, chewing on greens all day, or is it crazy? Is Esselstyn going crazy? Or maybe he's a genius. Maybe he's figured out a way, and Nathan Bryan, to get oxygen into your cells all day long, and that could maybe really help prevent cancer. I don't know for sure, but I think it's potentially a great thing. So that, that old guy Esselstyn figured out how to prevent coronary disease. He might have also figured out how to minimize risk of cancer. So he's maybe on the double genius move. Deserves 2 Nobel Prizes. He probably won't get any. All right. Anyways, when you get inflammation around, let's say, an asbestos inhaled particle, scar tissue forms around it, and that scar tissue, excessive collagen, fibrosis, acellular, will cause hypoxia. That can cause cancer. When you get fibrosis in the liver from fatty liver or from alcoholic cirrhosis, that can cause hypoxia cells, transformation into cancer. So the point I'm making is infections and toxins can lead to hypoxia, subsequent cancer. Anything that causes hypoxia. Women, learn about estrogen. Yeah, it's nice that you wear a pink ribbon and you run around. That's nice, okay, but you should also be learning about estrogen because you could really protect yourself a lot from breast cancer if you learn about it. We don't got time to get into it much, but basically, the backbone of a steroid hormone is like cholesterol. You got an aromatic ring, a benzene ring with a hydroxyl group coming off. The hydroxyl group confers antimicrobial properties. The aromatic ring confers shelf stability. So it's in everything, okay? BPA in the plastics, it's got a phenol group here. Aromatic benzene ring, hydroxyl group. And they're going to tell you, oh, this new plastic's BPA free. It's a joke. They're just going to put something else in the center. Here's BPS with sulfate. So you still got the hydroxyl group. It's still going to be estrogenic. So use glass if you're going to store your water. Okay, we don't got time to go into chemistry of it. The liver excretes estrogens, and basically when you eat a meat diet, you get bad gut bacteria, and they will unconjugate the estrogen excreted by the liver, and that means it gets reabsorbed in your body. So meat eaters have much more estrogen because of the estrogen in the meat itself, but also because of the estrogen gets reabsorbed in the blood because the bad bacteria from the meat diet or a processed food diet unconjugates that. That's important to know because I know lots of women, every single woman in their family had to get a hysterectomy for fibroids at a young age. Okay, so my mom played tons of tennis. I think that kept her alive long. Got along well with my dad. I think that kept her along. My dad did the best he could for her. My mom was always joking around. She's like a comedian, kind of like Roseanne Barr, but nicer. Roseanne Barr can be mean sometimes, but man, she was always making everybody laugh. Here's one of my cousins, for example. My mom just adopted him as long as his sister wanted her to. This girl, her family had some issues where she came live with us. My mom would just adopt these girls. We'd always have like adopted people living in our house. My mom would detoxify people from alcoholism, friends and relatives. My dad ran a detox unit, so he supervised it, but my mom was the person who did it. This was my one of our friends, and my brother fell in love with her. And anyways, that was his girlfriend, and she came over to our house on a cold day with a mini skirt. I'm just gonna tell you, there's like a typical comment my mom would say. So she's wearing a mini skirt on a cold day. My mom would go, "Michelle, you are going to catch a cold in your pussy." Okay, that would be a typical thing. My mom would make comments like that all day long. She was always making us laugh. She was really funny. These are just some of her activities. She didn't have to work. My father sort of provided the money, but man, she did all kinds of good things. On the board of directors of an orphanage, minister of care, tour guide at the Art Institute, Frank Lloyd Wright Studio. She's a champion tennis player, ran the whole family. When she had her cancer, she made a religious pilgrimage to Medjugorje. It's like Yugoslavia, Bosnia or something. And, that was something that made her happy. I had a story about what happened. I screwed up. I didn't know diet. I just saved my mom's life once. We don't got time to go into it. So I got to skip that story. I called that lecture, The Purpose of Education. But I saved her life. I think I got her about 2 extra years. I wish I'd gotten her a lot more than that. And she got to see this grandchild. This grandchild actually was a preemie baby. And she, moved in with this family and took care of that baby for months and really helped that kid do well. The kid did really well. Typical day with my mom. Mother's Day was the biggest day of the year. Everybody come over, much bigger day than any other holidays. This is a typical way people felt around my mom, just laughing and having fun. Okay, mouse equivalents cause hypoxia, deltoid theory, dementia. I talked about it in my previous lecture on dementia. Stress increases cancer risk because the platelets are activated and they hide the cancer cell from the immune cells to remove it. And there's a whole bunch of things that do that. I got articles here like high sodium stress and caffeine. That's why they're bad. Excessive iron increases the rate of cancer growth. Like the egg white is no iron. That's how bacteria can get through the eggshell, but they can't get to the yolk. And what I'm saying is you can minimize your dietary iron. Americans are totally overloaded in iron because they eat too much meat. It happens to women after menopause. Excess iron, cancers all grow faster. You could have hepatitis B, but you add iron overloaded, cancer takes off. It can cause auto-oxidation, function like a catalyst. It's bad. I got like 6 lectures on iron at my YouTube channel. Okay, epidemiology. Ornish is a guy who put patients on a vegetarian diet and got great results for low-grade prostate cancer. If you're considering prostate issues, you should definitely read the Dean Ornish paper on that. It's great. Okay, what I'm trying to say is you got to forget about social thinking with nutrition. Well, I'm going to cut down on the meat. I'm going to cut down on the oil. No, it's like a 10 commandment. Thou shalt not eat meat. Thou shalt not eat oil. Honor thy fruit and vegetable. That's how you get the best results. I call my diet the Spartan Vegan diet. I used to be a wrestler and I kind of have that mentality. I just do what's good. I don't do anything that's bad. All right, I try not to with my diet and I'm pretty good about it. I never break my diet because why would I want to poison myself? All right. Okay, things that are low in fat. You want to eat low fat foods. How much fat's in different foods? I got a list here. You can look at it. So you're going to stay down around here, the low fat foods. I think potatoes, sweet potatoes, and rice are like the best foods, those starches. Oh, you also want to restrict methionine. It's an essential amino acid that causes cancer to grow. So again, that means going to be avoiding fat and avoiding high protein foods, okay, which means eating plant foods, all right? There's a lot of people who've had great results from that. What would I do if I had cancer? I barely got enough time, but basically, I would do what I'm doing, optimize all these things, and I wouldn't do any more aggressive treatments unless I absolutely had to. I would look at what the prognosis was. And what I'm basically saying is I wouldn't just run to the doctor and say, save me, I'm dying of cancer, and then just sit around watching TV. No, I would dial in every single thing I could do to not let that cancer grow. And there's a lot you could do. And what I'm also saying about T. Colin Campbell, we don't got enough time to get into it, but I wonder, would I really want to eat so much beans? Because I'm adding up all my protein. I'd probably cut down on beans too, because I know he says you're safe with 20% soy or 20% gluten protein, but I wonder, that's a mono protein where you're only eating one protein. What about when you're eating a whole variety of foods? Do you still want to reduce your overall protein? That's a long discussion. I can get into it in the research of a guy named Mitchell as well. That's another time for a big day. So here's the slides if you want to read them. We don't got much time. The irreducible minimum, what I'm basically saying is you're kind of on your own. Learn how to save yourself. I basically told you everything I could do. You decide for yourself what you want to do. I was going to tell you one quick story. And I also think love and social stuff is super important. This was a baby, one of my mom's grandchildren who was born, and the child was born very sick and septic shock. The mother didn't know any better, had been in a hot tub, her water broke, she didn't know it, got infected, septic shock, mom's dying on a ventilator. Baby is in septic shock. They're running a code blue on them at this private practice hospital. I get called over there to help make a decision. I really don't know much about kids. To me, they're like little outer space aliens. I only treat adults. And so I got this buddy of mine, Patrick Walsh. The baby, by the way, is named Patrick. I'm going to call him Patrick. Actually, a different name. I don't want to say his name. But he's with me, and he says, Pete, we're talking to the doctors at the private practice hospital. They got this scared look in their eyes. And he says, Pete, I don't know much about medicine. He goes, but these doctors are scared. They think this baby's going to die. Send him to the children's hospital where they got ECMO, endocorporeal membranous oxygenation. Give the kid a chance. So we say, okay, fine, we'll go for it. My mom, she's dying of cancer. She's got metastases all throughout her lungs. She's coughing up blood. She puts her cot, just like she lived at the house of the preemie baby for 3 months. She moves into the ICU with her little cot. She's coughing up blood every day constantly in the garbage can. She hides it from the nurses so they don't kick her out of the hospital. All day long, she's praying by this baby. She's putting Padre Pio on as well. I mean, I would say you're going to get transdermal absorption of estrogen. My mom, she's holding the baby's hand. I love you, Patrick. I am with you, Patrick. You are going to be okay. Everything is fine. I love you. And I think what happened is everybody thought this baby was going to die. He was code blue for 2 hours. He's on a ventilator for 2.5 weeks. We all thought this kid was dead, all right, or severely neurologically injured. And what I'm trying to say, I believe my mom's love for this little baby, gave him hope. It was a light in the darkness. And the kid came through it fine. The kid's doing fine. He graduated from college. This kid would have been dead without my mom, 100% guaranteed. So anyways, that's it. There's the grandchild with mama. So Merry Christmas.
Oh, Dr. Rogers, this was such a fabulous presentation. Thank you. And listen, I people say you talk really fast, and so we'll book more time for you next time. And I want to announce to everyone that you are going to be coming on monthly to Chef AJ Live, and you'll be back on Saturday. Sunday, January 8th, the second Sunday of the month in 2023. Thank you so much for this fabulous presentation, Dr. Rogers.
Thank you.
And thanks all of you for watching another episode of Chef AJ Live. Please come back tomorrow when my guest is Linda Tyler, and she's going to be doing a Christmas dinner. Take care.